Okay, here's another trig equation where the angle is not just a variable x, but it's an expression 2x. And so when that happens, we are going to set up the situation to have some substitution. So anytime you see that the angle in a trig equation, that the variable is not alone, it's an expression of some sort, we're going to want to substitute out that angle. And so we're going to go ahead and say that 2x is equal to some other angle r. So we're going to rewrite this as 2 times the cosine of r, and I'm just going to go ahead and set it equal to radical 3. I added the radical 3 to both sides because I know my next step is to isolate the trig. From here I'll divide both sides by 2 because I'm still isolating the trig, and I have the cosine of some angle r is equal to radical 3 over 2. I know that that means r should equal pi over 6 plus 2 pi n, or r could equal 11 pi over 6 plus 2 pi n. Pi over 6 and 11 pi over 6 are the two angles that have cosines equal to radical 3 over 2. We have to add 2 pi n to demonstrate that in addition, all of their coterminal angles will still have a cosine of radical 3 over 2. So this is the general solution, but it still isn't the correct answer. Our original equation had an x in it. This answer has an r in it. R was introduced by us, which is important that we get it back out before we fully finish the problem. So I'm going to replace that r back with the 2x. And same thing here. From here I want to isolate the x, so the easiest way I see to do that is to multiply both sides by 1/2. And we're doing that for both of these equations here. So we're left with x equals pi over 12 plus just pi n this time. Here we have x equals 11 pi over 12 plus pi n. So if I was only asking for the general solution, we'd be done. But part B, you'll see, asks us for what's the solutions on the interval 0 to 2 pi. Well, pi over 12 is both greater than 0 and less than 2 pi. So pi over 12 is on that interval, as is 11 pi over 12. Both of these fit the conditions to be in this interval. Now, the previous problems we've tried, since the general solution had plus 2 pi n in them, we did not have to find any more because adding 2 pi to any angle would clearly take us out of the interval 0 to 2 pi. But this time, because of the way the angle worked, our angles that have a cosine of radical 3 over 2 are pi over 12 plus just pi n, not plus 2 pi n. And so pi over 12 works, but also pi over 12 plus pi is going to be another angle that will work for us here. We could change pi into 12 pi over 12 so that I have a common denominator. Hopefully recognize that pi is really 12 pi 12, so they mean the same thing. Now when I add these two together, I get 13 pi over 12. That's another angle that fits this interval. And so that's another answer to our question, pi over 12 and 13 pi over 12. You may wonder, can we get another one in there? We might, so let's check it out. What about if I add, because 13 pi over 12, I'm supposed to keep adding pi over, adding sections of pi each time and seeing will that keep me within the interval 0 to 2 pi. So let me try it again. Let me add another 12 pi 12ths. That puts me at 25 pi over 12. You may not know whether or not that is on the interval 0 to 2 pi, but if you turn that into an improper fraction, well, it is an improper fraction. If you turn it into a mixed number, that's going to be 2 and 1/12 pi. So that's past the interval 2 pi, so we're not going to have that in our solution. All right. But what if we add another pi to 11 pi 12ths, because it says 11 pi 12ths plus any pi, any full pi. So we're going to go ahead and try that as well. 11 pi 12ths plus just pi, which I can write as 12 pi 12ths. That's going to give me 23 pi 12ths. Hopefully you recognize that is less than 2 pi, because 24 pi over 12 would be equal to 2 pi. So think about that. That's 24 pi over 12. And since I got 23 pi over 12, that's still in this interval. So that's another answer. So this time we had 4 answers in this interval, 0 to 2 pi. Typically we'll only have 1 or 2, but in these problems where we have some substitution, the fact that this b changed our period, it shrunk our period in half, and so our answers are going to occur twice as often as they normally would. So that's why we have 4 answers instead of just 2 on the interval 0 to 2 pi.